Good morning. Sensors and actuated devices. In this video, we are going to discuss about the amplification of sensor signals in signal conditioning. Signal conditioning needs amplification, filtering, isolation, like the various operations. Here we are going to discuss about the amplification. So many signals are very low in amplitude. In that cases, we have to amplify the signals as required for next processing. So here we are going to consider the operational amplifiers. The operational amplifiers have all the properties required for ideal amplification. Generally, it has the following properties. It has the high gain, input impedance is also high, low output impedance. For an ideal condition, we can say gain is infinite and input impedance is also infinite and output impedance is ideally it's 0. So its operational amplifiers are available as in the IC packages, either single or a dual or a quad op-amp. And here we will first see as the inverting amplifier. So inverting amplifier, it inverts. Whatever the input is given, we are going to get as the inverting signals or also amplifications. So the gain we are going to get by this feedback and the input resistance. So this is what going to be happen. So V out equal to feedback resistance divided by the input resistance into input voltage. So negative indicates the inverting. We are going to invert the signal, that is 180-degree phase shift. And non-inverting amplifier, the non-inverting amplifier, the input is given to the positive terminal and the negative terminal is it's given to the feedback connections. So here the output is V out equal to 1 plus RF, that is the feedback by the input resistance into V in. So we can write as a gain, we can write V out by V in equal to 1 plus feedback resistance divided by the input resistance. Here no phase shift. And differential and summing amplifiers. So the differential amplifiers, if you see here, the differential amplifier difference between two terminals, that is input terminal, positive input terminal and the non-inverting input terminal is amplified. So the difference between two signals, that is V2 minus V1 difference, and it will be amplified by a factor of RF by Rin. So RF is the feedback resistance, Rin is the input resistance. So V out equal to RF by Rin into V2 minus V1. So the gain is given by these resistive components. And another one is the summing amplifier. Here we can sum the various voltages. We can get the signals from various sensors like V1, V2, V3, all we can add it using this operational amplifier. We are having a feedback resistance also. So R1, R2, R3. So that is we are going to get as RF by R1 into V1, RF by R2 into V2, then RF by R3 into V3. This is what the output. We can add any number of signals. And suppose if R1, R2, R3 is equal, we can take it out as V out equal to minus RF by, that is RF by R into V1 plus V2 plus V3. So if it is, we consider R1 equal to R2 equal to R3 equal to R, then we can take it as commonly. So the output is minus RF by R into V1 plus V2 plus V3. So this is the inverting summing amplifier. So negative sign we are having. The same thing can be used for the non-inverting also. And also operational amplifier can be used as a comparator. So we'll come to the diagram, that is we can see this is the operational amplifier. The input is given to the positive terminal. The reference voltage is given to the inverting terminal. First the input is less than the V reference. We can look at this condition. V input is less than the V reference. So at that time the output is in that minus VCC. There is a saturation condition, minus VCC. So again at low, the output is low. Now we are going to increase the input V in. It's going to be increased. When the V in goes above the V reference, then the output switches from low to high. So plus VCC, there's again a saturation level, and we are going to get output as a high value. So this is what happening in the comparator. When V in is less than the V reference, the output is low. When V in is greater than the V reference, the output is high. So this is what the operational amplifier works as a comparator. The operational amplifier can be worked as a inverting, non-inverting, that is voltage follower, and the differential amplifier, summing amplifier as a comparator. These operational amplifiers are very helpful in signal conditioning. Thank you.